Hello everyone again. Thanks for joining. Let's talk about this concept of complex event processing. Before we jump into this would be the agenda. We would be talking about what exactly is event processing first, and then let's understand what a simple event processing looks like, and then we'll go into the complex processing as a topic on its own, and then we'll deep dive into the same with a sample architecture, possible implementations, some use cases, and what all technologies are giving us the benefit of complex event processing as one of the main or highlighted features. So, what exactly is an event processing? Before answering that question, let me answer. Let me talk about first what is an event. Event can be understood as a record or a data set which has been generated by any of the systems that you have in your enterprise ecosystem. Event could be as small as a change in a measurable quantity. For example, your inventories, your stock, or how much orders have been received in one day, or it could be another complex behaviors of the enterprise system, like your entire transactional records. So this as a basis of an event, when we process that in our systems or in our IT environments, is classified as an event processing system. It can process your data in a stream or based on how and when they're generated based on the business requirements. It could be real time, near real time, or it could be an EOD batch, which runs once a day and processes the events which have been collected throughout the whole day. The basic difference between, or I would say the major difference which classifies complex event processing and simple event processing is basically the variety and the velocity of which the data is being processed. Now, we call these terms variety, velocity. What exactly do they mean? Variety can be simply understood what extent or how diversified is my data. So let's take an example of a telecom domain where you have your data from the CRM systems, you have your data from the billing systems, you have data from the actual network based on the customer activities which they are doing on the network. That basically talks about the heterogeneity of the data that has to be processed to come up to insight which the business can use. Whereas velocity is what is the time frame of this data to be arrived and to be processed. Is the data coming near real time, or am I going to process it at the end of the day? Volume. Volume is nothing but what is the bulk of the data that I'm processing. How much data am I required to process in one meaningful execution of my engine? Is it in terabytes? Is it in bytes? What exactly is it? These factors, when combined together, then they can quantify the magnitude of an event processing system. It could be a typical complex event processing engine based on these factors, or these factors can define if it is a simple event processing system. Now, an event processing system typically is a transformation engine which takes your input data, it ingests it, it processes it based on your business rules, and then produces an output. So, in layman terms, you can say that we have an event source. It could be one system or it could be many systems within your IT infrastructure. You have one event processing engine, which is processing the data to extract valuable insight out of it. And then you have your response consumers. Like, what do you do when the data is processed? Is it a target analytical system, or is it a data store, a data lake, or a real-time decision-making system? These factors are your basic components of a complex or an event processing system. Now, this data set, as I talked about, as more and more organizations are becoming data-driven, could vary from a lot of things. Like it could be a web application which is running on a mobile phone, it could be a website, it could be your network elements, it could be a CRM system, and one thing which is very popular these days, IoT. It could be an IoT source as well. So looking at the variety of the data set which we have to process, that is the basic driver of the need of moving from something which was called as simple event processing to something which is called as complex event processing. Some examples of an ETL applications which can be used to do these kind of jobs are Informatica, Ab initio, IBM DataStage. Here I have just coined out only 3 proprietary tools which can do these jobs very well. And later on in the slides, we'll see that there are a lot more tools available in the market which can achieve the same purposes. Now, let's see what is a simple event processing system in slightly more details. Now, imagine that a data set is changing or a matrix around one measurable quantity has changed and you have to process it. For example, if as a marketing team of a company, if you introduce a product and you want to understand how many sales of that product have happened in one particular day, you can understand this based on the execution output of a simple event processing system, which can run on homogeneous set of data at a controlled frequency. Now, this controlled frequency, as I said earlier, it could be anything. It could be real-time processing, it could be near real-time, or it could be just a simple EOD batch, which runs and creates the outcome for the business to consume. The outcome of this process could be then used as in my data warehousing system where all my reports are being generated, where the trend analysis is happening. I can use it in another applications like showing the progress of the business, how the marketing should perform better, or what are the inputs and the areas where they have to more work and produce tangible results for the business. Now, these things can be cluttered together and we can define them as a simple event processing system. Now, let's see what a complex event processing system is. Complex event processing as a concept on its own has been in the market for a long time. It was coined out in early 90s in Stanford University by a professor by the name David Luckham. He has written a couple of books as well on this topic, and there are a good amount of material available online as well. What exactly is complex event processing? Just imagine that you have a series of simple event processing that are happening at the same point of time in a centralized engine. That is the layman definition of complex event processing. You're processing a lot of heterogeneous data and creating insights out of it at a real point of time. For example, fraud detection system. In a fraud detection system in any domain, let's take retail banking, for example, you have multiple systems which are running at the back of it. If the frauds are detected after a day they have happened, there is very little that an organization can do on it. However, if these kind of activities are tracked and are captured at the very start of the activity itself, then the organizations can take a lot of measures on top of it and to avoid it in next time, in future as well. CEP on its own is nothing but a pattern recognition system. Now, the system of CEP, the concept is that you process the app, you process the events coming in at near real time, you generate the analytics or the value out of it, and then it hits your database. Later on in these slides, we'll see how a conventional data processing and complex event processing on a very high level architecture, they differ to each other. Now, as I said, CEP works on a very simple concept. You have your heterogeneous sources of data. It could be 50, it could be n number of sources which are generating your data set. We collect it, we act on it. We detect what exactly is the pattern that these events have been following. And based on the outcome, we act on these events to actually create something very insightful activity for the business. As CEP as a concept is these days implemented in a lot of areas, and because it provides a lot of features like operational intelligence, you have real-time data processing and you can actually act on the data on real time. You can capture and you can work according to the variety, velocity, and volume of the data. You have a pattern, you can recognize that pattern very easily on the fly. These are some of the benefits which complex event processing as a system on its own provides to the users. I'll just see if there are any questions. Okay, no questions so far. Fine, we'll move ahead. Now, this diagram basically shows us two different processes. One is a conventional data processing engine, where you have an ETL engine which is consuming all the data and processing it based on business requirements and loading it into a data store. On top of it, the end users or your reporting applications or your analytical engines can fire SQLs and get the insight value what they are looking for. Now, this is just one type of implementation. As I said, it is an ETL. You extract, you transform, and you load. Based on the requirements and based on the technical implementations, it could be anything. It could be ELT as well, where you load first and then you transform. The overall idea is the insight of the information or the data is only captured or is only available once it has been processed completely and is stored in a data store. Let's look at what a complex event processing on the contrary does. Now, you have the same stream of input data coming in from your different sources. You have a complex event processing engine, which has its own data processing rules, where it stores basically the metadata of processing this information coming in from sources. Like, what all patterns do I have to look for? What exactly is the trigger event where I have to process this data? For example, it could be that if someone has done a transaction of 10,000 pounds in just one day, then that act as one of the triggers to the events. Or if the usage of a mobile customer is going beyond 10 GBs in a single stretch or over a period of time, that act as a pattern. If these patterns can be detected based on the events in real time, you can provide a real-time analytics, and you can always have dashboards on top of it, which tells the business how their data is being performing. Another example which I would like to take is, let's imagine the case which I took, the example which I took before, and where we were talking about a sale of a product. Now, if your processing engine is a conventional processing engine and your frequency is, let's say, EOD, you would not come to know how your product is behaving in the market right now. For that, you need to have real-time capabilities and different factors associated to it as well. Like, how's the market reacting to it? If your organization has the capability, then you can integrate social media as well, where you understand what are the customer sentiments, how are the customers actually reacting on to the product which has been published into the market. However, all these analytics extracted, still you have the functionality of storing this data into a data store, where later on more and more analytics can be done, which can again help you refine your patterns, or which can do a proper overtime trend analysis. How did we do in 1 year? To achieve such kind of questions or the answers to them, you can still have the flexibility of loading the data into a data lake based on the organizational requirement, and the data is still available for anyone to query on it. So this is basically the advantage which a complex event processing system gives to the end customer. You have a basic ability to draw the analytics out of the data before it hits the database, and it gives you a leverage of time. Moving on. Now, this is a small graph which tells us the value of the data which has been processed over time. Let's say anything that we do before an event has occurred is nothing but a predictive analysis or proactive actions which have to be taken. The event has not occurred, however, we can still take an action on top of it. That portion is called as predictive analytics. Now, let's talk about this time frame when the event has actually happened. What happens after the event has happened? Each and every organization has their own definition of real time. What exactly do you call real time? As I use the example of banking systems, fraud detection in a bank system, for them real time is within 5 minutes. For another organization, it could be 1 hour. For some other organization, it could be 1 day as well. So any processing which happens within the definition of real time for one particular organization based on the data they have, that is called as complex event processing and real-time processing. Basically, anything which happens on that data after that real time has been achieved or has been passed is basically your historic data processing. Now, this red line, for a lot of organizations, it could be even much more flatter as well. It all depends on what exactly is the type of data they're dealing with and what are their business problems and their business requirements. So this can very well vary based on the organization and the business function needs. Let's take a No question so far. Let's play a small quiz. You're walking down the road in your town and you hear the church bells going on. Now, this on its own is an event which can happen any time of the day, and it could mean any different. Later on, you also observe that there are a lot of people who are clapping around the church and they're smiling, which denotes that they're happy. Third thing that you notice is a very beautiful cake. Now, looking at these three events, they are basically mutually exclusive events which could happen any time of the day, any situation whatsoever. Then you observe a person in tuxedo and a lady in white gown. If you consider all these four events together, then your mind tells you that you're observing a marriage which is happening there. This outcome, these four heterogeneous events, which on their own do not have any impact or any overlap with any one of the other one, when happens together and we process it, we can come out to a meaningful conclusion that there's a marriage happening. This conclusion, which your mind did just now, is nothing but what exactly is complex event processing. You have heterogeneous events happening, which on their own do not have any overlap with anyone else. However, when you took them together, then they give you an insight that there's a marriage happening. Now, let's see a sample architecture. Here we have our event collection system where you could have a different variety of sources. You could have World Wide Web, you could have your warehouse data which is coming in, you have multiple applications, you have mobile devices which the end customer is interacting with your systems, you have social media, you have network elements and traffic as well. All of this data is being fed to a complex event processing engine, which is being processed against the processing rules which have already been stored or the known patterns which the business defines how you have to actually perform one particular action. And on top of this, you are creating real-time dashboards and analytics for your business to utilize or consume. And this data can still be utilized to response back, either store in a data lake or create reports on top of it or through messages to the end customer. And later down the slides, we'll see some of the examples where complex event processing plays a very vital role and where it has actually, where you would see it happening in real time, unknowing that at the back of it, there is a complex event processing engine running. So the next slide basically talks about some possible implementations. The first and my favorite one is the algorithmic trading, where complex event processing plays a very good and very important role these days. Now, most of us would believe that the stock marketing trading all around the world is done by intelligent people who have an understanding of the market and how the company shares are traded and how they vary over time. However, these days, with the leverage of information technology, complex event processing is one of the key factors where the tradings are done by computers rather than human beings. It is very interesting to find out that almost 70% of today's stock marketing transactions are basically carried out based on a computer decision and not on human mind or human ability to process this much data. Let me take an example and try and explain how this is possible. So let's say that we are reaching towards September, and as everyone know, iPhone launches its new phones usually in September. And in September, the market basically is anticipating a phone, and a lot of companies and a lot of traders are anticipating a spike in the share prices. At just before the announcement, let's say there is a leak on the design, and people have seen it now before the launch, and they started tweeting, they started putting posts on Facebook that they don't like it. Based on this decision, if I can analyze the stream of data coming in, the analytics, the sentiments which are coming in from the real-time market, I can either decide to sell off the shares or I can decide to buy on shares. Recently, an incident happened where there was a tweet from Elon Musk based on which the company lost a huge amount of money in stock market. Had I known about that tweet in real time, I could have sold my shares at real time and avoided that catastrophe. This is the power which complex event processing can give you. It can churn out the data in with a latency of milliseconds in certain implementations based on how it is done and the data which it has to process. Another great example is your self-driven cars. Now, this implementation can be done based on many other combinations of technologies and ideologies like artificial intelligence, machine learning. But the basic thing which an autonomous car is doing is processing the data at a very complex rate at a very fast speed. What is my distance around? What is the distance between my car and the car ahead of me? Or where am I positioned in relative terms to other automobiles on the road? Is the road wet? Am I speeding too much? All these factors are basically data points which the sensors built within the car are providing it to the central processing engine, and your car is taking decisions at real point of time. Once it is able to do it, then only it is possible for a car to perform in a real-time situation. Another example which I would like to take is a telecom domain example, where in telecom, you have to respond fast. If you're not fast enough in processing and understanding your data and creating a valuable insight out of it, I think you already lost the game. So in certain examples, you can see that as soon as your data or your usage of any commodity like calls, SMS, or data itself makes an unusual spike, you get an alert from your data provider or your telecom provider. I'll elaborate this example more. Let's say all of a sudden you have started sending a lot of SMSs, and the operator is understanding that your rate of sending an SMS is more than, let's say, 500 a day. It can classify you as a telesales marketing, which is using their product against the terms and conditions, and it can take corrective actions on top of it. But if just imagine these actions or these corrective measures are taken after a day or 2 days for that matter, they don't really matter. So as someone has very rightly said that data is the next oil, I would just like to add that data differs slightly from oil because a barrel of oil may cost the same or higher even after a day. But the value of the data, if harnessed at real point of time, is the highest. And as soon as you move down the timeline, that reduces. This is moving on to a sample scenario of a telecom use case. So as I said, let's say that there is a campaign which has been created. For people who might not be aware of what a campaign is nothing but a next best action which a telecom operator takes to give extra value to the customer and obviously make profit out of it. Usually there are two types of campaigns, inbound and outbound. We are taking an example of an outbound campaign where the telecom operator, based on the permissions and privileges which the customers have set, they are taken actions and an event or a campaign is managed. So let's start from now. Let's take a start where the campaign has actually been initiated by the organization or your telecom operator. The campaign talks about the data consumptions of one particular user. So let's say the trigger point is that if the consumer has consumed 1 GB worth of data in 2 days, that is my trigger point for this particular campaign management. And on this basis, we take appropriate actions. If he has not done, then we send him a reminding message that, hey, if you do it, you have X and Y benefits. And on the other hand, if the customer has already done this, then we send him an alert that you have consumed this much amount of data in this period. Based on this, if you take an XYZ pack, you would have extra benefit with a very low cost. If I'm sending these kind of campaign messages to the end customer at a real time when they're actually happening, it's more likely that the customer would buy it. Another example could be that out of the blue, if you make an ISD call to, let's say, America, and this is not something which you have done in the past, as soon as the company or the telecom operator understands this, if within 5 or 10 minutes, if I send you an offer package that next time when you call, if you buy this package, your call would be 50% cheaper, highly likely chances that the customer would buy it. But at the same time, if these messages or these campaigns are sent out to the end customer after, let's say, a day or two, they don't mean that much value to the customer anymore. Because You need to hit the customers with the right product at the right time. Here, the timing and the content of your processes and products is really critical. That's how complex event processing helps you in achieving that. In this entire diagram, you'll see all the events which have been marked in yellow are basically the events which your complex event processing engine is creating or generating based on the inputs coming in from variety of sources, like the access to the data usage of a particular customer, the profile of a customer. Is he a prepaid customer? Is he a postpaid customer? What are the preferences? Has he allowed me to throw him an SMS? Or if he has allowed this means of communication, what is the preferred way of or mode of communication? Does he prefer to get an email or an SMS or a call instead? So these are variety of systems which are feeding into my complex event processing engine, and based on these events, the complex processing event engine is taking or creating triggers which can down the line be sent to the customers, and an appropriate action can be taken. On a very successful journey of various parameters, this campaign can be marked as successful or can be marked as unsuccessful based on multiple things: the behavior of the customer, the availability and the validity of the package, and is there anything other than this which can be offered. So just imagine a organization where the business team is taking these actions at real time, and based on the customer behavior and how the market responds, they have the ability to change these processing rules on the fly. You have the data coming in, you have the leverage of processing the data at real time, plus you have the ability to change the transformation rules on the fly itself. That gives the organizations an advantage which most of the organizations are after. That is real-time processing of data and actually creating an insight out of it. So moving on, this slide basically talks about supporting technologies. As in the session, I talked about these implementations of complex event processing engines through, but there are multiple platforms available. You have, on one hand, you have proprietary softwares like Ab Initio, TIBCO, IBM WebSphere. Oracle has some products on this. On the other hand, we have a lot of open source tools as well. If you explore the internet, you'll find out that there are people who have coded their own complex event processing engines themselves. So what I'm trying to say here is that the market is huge. You have n number of products available. It all depends on the business requirement. It all depends on the budget that the company or the organization is willing to spend on this topic, and what is the maintainability of the product. Needless to say, open sources and other features or the other product which are available in the market compared to the proprietary tools might be cost effective in the start, but later on, the implementation cost and the development of it plus the maintenance of it may add the whole amount of cost, which may be less than, in certain cases, the original operational cost of buying one particular engine. So this is basically one of the decisions which each organization has to take on its own capabilities, plus the amount of data they are processing and what exactly is the business requirement and what satisfies their achievement of business target. That would summarize my presentation and this brief introduction. I think, yeah, we are almost on end of the time. We'll wait for any questions if anyone has. Okay, so we have a question. What are the important factors we should be considering while building these CEP engines? So that's a very good question. Now, a CEP engine may have a lot of different factors which are associated on to the implementation of it. For example, what is the type of data that you're processing? What exactly is the processing velocity that you need out of your system? So I would say variety, velocity, and variance of the data is one factor that you should definitely consider. And what is your requirement? What is the business requirement or the implementation use case? Based on these factors, I think you should have a pretty good answer on to how your CEP engine should be deployed, or do you actually need a CEP? And of course, if you're going for proprietary tools, then things like the cost of the system itself may also act as one of the factors that you need to consider. I hope that answers your question. The next question is, please let me know if it is extension of CDA framework. Okay, so CDA framework, collect, detect, and act. That's one of the engines from one of the proprietary tool in the market called Ab initio. It's very funny enough that CDA is basically an implementation of complex event processing. So CDA does nothing but the same thing. It collects the data, processes and detects and acts on these events on a real time based on the business logic. So in my opinion, it is basically an implementation case of the concept of complex event processing. Next question is, do you have any recommendations regarding tools out here from your experience and why? Based on my past experience and the implementations and the success stories that I have seen in the past, I would recommend Ab initio as it contains multiple tools under its umbrella. There are engines like CIP, Customer Insight Platform, and CDA, which has been called out by one of the participants. So if you look at these engines are basically very well supported to start off. The support from this organization is unbeatable, and I haven't observed or seen the support which the Ab initio provides compared to any other provider of the tool. Plus, there are multiple other features that the type of data and the volume of data it can handle on the fly is unmatchable. I mean, in some of the implementations, we have observed that Ab initio can process around 50 to 60 terabytes worth of data in one day with a minimum latency of from seconds to a maximum latency of 5 minutes. Now, if I'm able to process this huge volume of data with a maximum latency of 5 minutes, I think I'm achieving my business goals. I think I'm making the right decisions at exactly the point when they are happening. So out of this, some of the tools which I've highlighted on my presentation, plus the tools which are available outside in the market, my first preference would always be with Ab initio because of the support it gives, the flexibility the tool has. On the fly, the business can change rules without any process of implementation. I mean, you don't have to go from dev test to production with tools like Ab initio. So in my opinion, this tool suits most of the requirements the best way it can be handled. I hope that answers the question. You can reach back to us anytime with any further questions you may have, and I would try and take it up to the best of my knowledge. In the last slide, I have mentioned a couple of references which I have taken to build this presentation. Of course, there are multiple other sources of information available from different online books to blogs to a lot of material which tools the companies have created on their own on the website. You can go through them for more information on it, or you can just drop us a message. We surely be happy to help you and advise you on your data processing needs. Okay, if there is no further questions, then thank you very much. Hope you enjoyed it. If you have any further questions, please feel free to get back to us. We'll be happy to answer them and help you on your data processing journeys. Thank you.